So, good morning, everyone. Welcome to the lecture 15 of Solving and Computer Programming. In today's lecture, we are going to learn two different concepts. One is called as function overloading. Second one is we are going to function. Okay. So these two are very important in the. So you should know why used and what is the benefit you are going to get if you are using function overloading or inline function, right? So let us start with overloading the function names. So C++ is allowing you to define more than one function, right? With the same name. Okay, like I told you, if you want to go for addition of two number program, you want to add a function with name add. Okay, so you can define multiple add function in a particular program. But the thing is that they have different definitions, right? That's why it is saying more than one definition, right? So maybe one addition of two number addition function takes input as two parameter. Another addition of two number is taking three parameters. Addition of numbers taking three parameters. So this is with two parameter. This is for three parameter. But if you see, the name of these two function is same, right? So that is called as we are overloading the function names. So it is very convenient for situation in is needed for different number or types of argument. Sometimes the number of argument is same, but the type of the argument is different. For example, in one case it may be int, another case it may be double, right? Suppose addition of two number program, you have written multiple functions with the same name, but the type of argument is different. Like here I have one function is there with int, another function is there with the name double and double. Or you can say another function is there with the type is int and double, right? So in such a way, what you can do, you can differentiate one function with another function. So overloading a function names means providing more than one declaration and definition using the same function name. So you know, first you are going to declare a particular function, then you are going to define. So if you are using more than one function, right, with the same name, so you can go for more than one declaration followed by more than one function call followed by more than one definition, right? So see here, this is clear cut example. Here, if you, I will tell you, so find the average of two number, right? So you know that you are calculating average of the two number. If the first number is n1, second number is n2, average is calculated as n1 plus n2 divided by 2, right? But if I'll tell you, find the average of three number, so you will write n1 plus n2 plus n3 divided by 3 will give you the average of three number. But if you see in these two scenario, the type of argument is double for both the function and the name of the function, that is ABE, is same. Okay, one function takes two parameter n1 and n2, which is of double type. Another function takes three parameter n1, n2 and n3. All are double. Okay, so if you are supplying three parameters, then it is invoking function number 2. But if you are giving two parameter, it is giving input to, it is giving that value to the first function, right? So compiler checks the number and type of argument. Here the number of argument is 2, here the number of argument is 3, right? The compiler is going to check two things. One is the number and the types of argument in the function call to decide whether to call the function number 1 or function number 2. So suppose if you want to provide the value cout AB of 10, 20, 30. So AB is a programmer defined function which takes three parameters 10, 20, 30. So it will automatically invoke to your second function definition. Okay, but if you supply AB of 10, 20, okay, AB of 10, 20, so it is 2. So it is going to invoke your first. right? So based upon the input, compiler is going to provide that input to one of the definitions, right? Wherever it met arguments, right? So overloading the function, if you want to overloading the must have different number of formal parameters. Okay, you can take integer one function with integer another function with integer. That is not allowed. So at least your formal parameters are and their types are different, and or must have at least one different type of parameter. If one is integer, if another is double, then that is allowed. You have to ensure that if you are using multiple functions, so all the functions are taking at least one different data type, right? At least one. Like I told you, int, then another one is int double, or another one is double int. That is allowed, right? And it must return a value of the same type. Return type plays an important role in the case of function overloading. So you have to ensure this thing whenever you want to overload a particular function. So let us take another program, the same program in the complete picture of the particular program. So this program illustrates the overloading the function, and the name of that particular function is AVE. So you know that execution always starts from int main, that is the main function, right? So you have written using namespace std. Then you have written cout the average of 2.0, 2.5 and 3.0 is you are calling a function with three parameters. One is 2, another is 2.5, another is 3. So you can see the top of the main function you have already written. Okay, the function declaration. You have written there is a function AVE which takes two parameters n1 and n2. Right? There is another function with the same name AVE, right? But takes three parameters n1, n2, n3. Right? So whenever you are calling three parameter, it is going to invoke this particular declaration. Okay. So we have written for this particular function, we have declared here. And the definition of that particular function you have mentioned here. Okay. So whenever you are calling 2.0, 2.53, 2.0 is copied to N1, 2.5 is copied to N2, and 3 is copied to your N3. Then it is going to calculate 2.0 plus 2.5, okay, plus 3.0 divided by 3. So 3.0, you are going to get 2.50 as the output, right? But in the second cout statement, you have written the average of 4.5 and 5.5 is average of 4.5, 5.5. The declaration for this particular function you have declared here, right? And the definition of this particular function you have mentioned here, right? So this 4.5 is copied to N1, 5.5 is copied to N2, and here you are calculating 4.5 plus 5.5 divided by 2. So it will come 5.000 as the output. So what you have here, the same function name you are using, you are declaring the functions with the same name with different argument. You are calling also differently with the same function name, but the argument is different. As the argument is different, they are treated as different functions. Okay, but their name is same. That's why you are overloading that function, right? So like that, you can declare multiple functions and you can give different inputs to get your output, right? So let us go for our previous example we discussed in the last class, that is a pizza buying example. We are giving the input of a small pizza and a large pizza, and finally we are concluding whether we will purchase the small pizza or the large pizza based upon the price. Okay. So today we are just revising that program, right? What is mentioned here? There are two types of pizza. One is called as your rectangular pizza, another is called as your circular pizza, right? So rectangular pizza is now offered. So you have to change that program such that it will take two input instead of small pizza and large pizza. It is going to take the rectangular pizza. Another is your round shaped pizza, right? So you know that if there is a rectangle the calculation of area is different, right? If it is square, sorry, if it is a circle, it is different, right? So what we did, we have to change the input and add a function to compute the unit price of a rectangular pizza. For example, you can see here what we did here. The function name is unit price and its return type is double, which takes three parameters. One is length, another is width, another is price. If it is a rectangular pizza, so you have to give input the length and width. If you specify length and width and cost, so it is going to calculate what is the price, right? So you know that calculation of area for the rectangle is nothing but length into width. With a given length and width, you can calculate the area, and finally you have to return price per area, which will specify the unit price of the rectangle pizza. So what we did here, previous program, we have a function. Previous program, if you remember, you for the circular pizza, okay, round shaped pizza, okay. So you have already a function. We are using the same function here. That is the unit price function. So you need to define a new function with the same name, which takes different parameter. In the previous case, it is taking diameter as a parameter and price as a parameter. But in this case, we are taking length and width and price as a input parameter. So based on that, you can calculate. So let us see. So this is the program. If you compare with the previous one, I am not going in detail about this particular program as we have already discussed. I will go only the modified part. Earlier, you have mentioned the diameter and price. You have mentioned the diameter, another is price. Diameter is integer type and the price is your double type for a round size pizza, right? But now I have added the same function name. You can see here. Here it is a unit price. Here also the function name is unit price. Which this function takes two parameters. One is int, another is double type. But here we are taking int and double type. Okay, that's why this is called as function overloading. Same function with different parameter or argument. Okay, so if you go for a rectangular pizza, you need to specify the length, width and price. Three things you have to mention, right? So after taking the input of the parameters required for round pizza, what are parameters you require? You require diameter. That's why you are asking user or you are prompting the user to enter diameter and price of the round pizza, right? Then, okay, then you are giving input for your rectangular pizza, that is length and width and your price of a rectangular pizza. So once you specify these parameters, you are calling the function here for your rectangular pizza. You are calling this function, the same function with different argument for your circular pizza, okay, or the round pizza, right? So once you are giving the input, okay, or once you are calling this function, the function declaration is done here. This is part is your function declaration and comment, and function definition we have mentioned here. Function definition. So what we did here, earlier you are for the round shaped pizza, you are giving input as diameter and price, okay, and you know the calculation of area is nothing but pi r square, okay, pi r square. So pi value you know that is 3.14159, and as you are giving diameter, radius is nothing but diameter divided by 2, right? R is equal to d by 2. So you have taken here d by 2, right? So here you are calculating radius is equal to diameter divided by 2. As 2 is an integer, you are converting 2 to double by applying typecasting. So once you calculate the your radius, you can calculate the area, and finally you have to return the area. This we are doing for a circular pizza or a round shaped pizza. But now we have added for what? We have added for rectangular pizza. So rectangular pizza case, we are in our input is length and width and price. So once length and width price is given to you, you can calculate length into width, okay, L into W, okay, is nothing but your area because it is a rectangular shape, and finally you have to return price per area and print the output. Okay, wherever you are getting the price is, suppose the price of rectangular pizza is more, then you will prefer round shaped one. But if the price of round shaped is high, okay, then you will choose the rectangular pizza. 8.5 as input for your round shaped pizza. So here you will calculate. And for pizza, you are giving 6, 4, and 7.55. That is the cost input. So you are going to calculate length into width, right? Length into width. Okay. So accordingly, the calculation is done. Square inch is of round pizza, and in the rectangular pizza case, you are getting $3. Right. So obviously, you will refer the round pizza because its cost is low. Right. So in this way, you can revise the, your pizza example, right, by incorporating rectangular shaped pizza in addition to your round shaped pizza. So next we are going to discuss, that is automatic type conversion. So see here, there is a particular function we are using that is called as MPG. MPG stands for miles per gallon, which takes two parameters. One is miles, another is gallons, and both are double type. Okay. If you are supplying the miles and gallons as an input, it is going to return miles divided by gallons, right? And its return type is double. So the question comes, what will happen if MPG is called in this way? What is the way? You are supplying 45 for miles and 2 for gallons, right? What is that? You want to output, see out, MPG 45. That means 45 you are supplying for miles, 2 you are supplying for gallons. Then it will print a message miles per gallon after calling to this particular function. So once you supply this 45 and 2, it is nothing but which type? It is nothing but double type. But 45 2 is what? It is integer. So integer is going to convert it to your double. So it will be treated as 45.0. It will be treated as 2.0. So while you are returning, it is going to calculate 45.0 divided by 2.0. So whatever value is coming, it will be printed here and with a message miles per gallon. So that is called as automatic type conversion. We have not explicitly mentioned here. Like previous case, I told you, if you are dividing 4 divided by 2, okay, suppose A divided by B, A value is 4, B is equal to 2, you need to mention double A, okay, double A divided by B. Or you have to specify A divided by double of B. Right? In this way, you are mentioning, right? So now it will do automatically because already you have mentioned the types. Automatically it will be convert 45 to 45.0 to 2.0. Now let us see. Okay, so in this case, that is MPG. But here the argument is your goals and misses. Okay. Previous case, both parameter, if you remember, that is double and double. And double. But the input is INT and INT. But both is having the same function, that is MPG. That is possible because that is called as our function overloading. Same function with different argument. So if you supply the integer value, what is it is going to do here? It is going to calculate goals minus misses. Goals minus misses it will calculate. But if you supply the double value, it is going to calculate miles divided by gallons. So based upon your input, okay, to this particular function, compiler will choose appropriate function definition in order to calculate the things, right? So here you can see, if you are supplying MPG 45.45 and 2, now it will not convert 45 to 45.0 or 2 to 2.0. Okay. Two function, okay, with the same name, okay, with different argument. So now it will not going to check your miles and gallons. It will assign 45 to your goals and 2 to your misses and it is going to calculate 45 minus 2 miles per gallon. That's why the compiler chooses the function that matches the parameter types. So the measure of perfect growth will be calculated. So you have to ensure whenever you are supplying the value, you may be thinking that the output is going to come like 45 divided by 2, but it is not going to calculate 45 divided by 2. It is going to calculate 45 minus 2. Okay, that purely depends upon what kind of parameters you are giving input to your function definition, right? So do not use the same function name for unrelated function. Like you want to do addition of two number program, another person want to do subtraction of two number program. Okay, or you want to build a common program for addition and subtraction. Don't take addition function for the subtraction as well. Okay, so if they are related, you use the same function name. But if they are not related, don't use such a terminology, right? Okay, so these are the questions I think you can solve. We already discussed what is top level design. Then you have to describe that type of task we have seen so far that could be implemented in C++ function, whether it may be a predefined functions or it may be a user defined function or programmer defined function. Or you can see that different principles like black box, procedural abstraction, information hiding. We have also discussed about local variable and global variable, and you also know the fundamental idea of function overloading, right? Now the next point of discussion is nothing but C++ standard. So you are very much habituated with the first header file that is called IO stream, input output stream. Okay, this header file contains the function prototype for standard input and output. So C in, C out you are using, for which you are including a standard library header that is IO stream. Apart from that, also we are using IO manipulation that is called as input output manipulation, or we call it as stream manipulation. Stream manipulation. That may be input stream or output stream. So in that case, if you want to apply some, you want to use some functions, then you can use the header file IO manipulation, right? Similarly, for the mathematical type of function, math library function, you can use CMath, right? And for the function prototype for conversion, number to the text or text to the number, or if you want to go for memory allocation, in later classes you will know how to dynamically allocate the memory, right? Random number, you want to generate a random number out of 0 to 10, okay, or 0 to 100, and various other functions are supported by this particular header file that is nothing but CSTDLIB, right? Another one is C time. C time is nothing but if you want to know that what is the execution time of your particular program. From the starting, from the input to the final output, you want to see how much time the program took. For that also you can use C time. Or if you want to do some program with respect to the time and date, then you can use this standard header file. Okay, that is C time. So now you can see here, there is a concept of stack. So you may not understand, but I will tell you in overall. Like if you go for a marriage party, right? In the marriage party, whenever you are going for this party, right, what happens? The very first counter, you have what? You have plates, right? So if you see, the plates are arranged like this, right? So you can see here, which plate you can take. You can take the plate which is available at the top of this particular rack. Okay. Okay. So the plate which is inserted at the end, which plate is inserted first? The bottom one. Okay. Then the second plate, third plate, fourth plate, like that, right? So you are picking the topmost plate, right? So the plate which is inserted at the last, you are going to pick that plate. Okay. And the plate which is inserted first is going to be out last. So this is called the concept of a stack. Which follows which structure? It is follows one structure that is called as last in, first out. Whichever is inserted first. Okay. So whenever you go for memory representation, I will tell you in one class specially. there is a stack representation, heap area, stack area, some unassigned area, assigned variable, unassigned variable area, assigned variable area. So memory is divided in various parts that we are going to discuss in later classes, right? So this is the called as the concept of stack. So now why I am telling you this? Because in this program I will tell you about the square function that is used to demonstrate the concept of function which uses your stack and activation records. See here, execution always starts from your main function. So inside the main function you have written int a is equal to 10, and you know the value of a equal to 10 is limited to this particular block only, which we call as a local variable. What I am doing here, I want to print the value of a, so I have written a. So what it will print? It will print 10. Then there is a message it will print because it is in the double quote, so it is going to print square. Then I have written square of a. So I am supplying 10 as a value for a, and I am calling a function square. That's why you have declared the function here. That is, your function name is square, which takes a data type, that is int. Okay, which takes the parameter type is your int, right? So now whenever you are writing square of 10, to calculate this particular function, it will supply the value of a to this particular variable x. Okay, so what it is going to calculate? It is going to calculate 10 into 10. So 10 into 10 is 100. So it is going to replace the square of a is 100. Right? So in the output you are going to get 10 squared column 100. Right? So now you see what is the representation in the memory. So first step is operating system invokes the main to execute the function. I told you, right? So there is a return location R1 is here. Okay. So it is calling your main function. Okay. Step 1 is over. Function call after the stack, after function call stack after step 1, what is happened? The return location is your R1, and it is written that a value is 10. So as you have written int a is equal to 10, it is occupied some memory computer, and it is assigned the value of 10 to variable a. So similarly, you have a lot of variable declaration, right? Like I told you, in a plate, the plate which is inserted last you are going to pick. That is called as your top stacks. Okay. Plate which is at the bottom is called as your bottom of stack, right? Located to the top of stack, right? So this is nothing but the whole thing, whatever we are representing in this one, it is called as activation record for function. Main functions activation record, right? Now what happened? Calling inside the main, that is nothing but your square function. So your step 2 is main function invokes the square to perform the calculation. So we are representing another return location R2, right? What you have to do? You have to calculate the square. So that is the third step. After the function 2, you have two things. One is your return location R1, which is nothing but a is equal to 10. Again, you are supplying the value 10 to the square function, which is in the return location R2. So earlier, if you remember, the top of stack is pointing to the last plate. Okay, because that is the topmost plate, right? If there is a single plate is there in a array, that is nothing but the top of stack. But once I am inserting another plate, now the top of stack is not the bottom one. The top of stack is nothing but the top one. So what happened? Now the top of the stack is changed. You can see here, the top of stack is pointing to your square function, right? Now what you will do? You are going to calculate the square. That is nothing but 10 into 10. Okay. Once 10 into 10 is calculated, the top of the stack will be removed because that calculation is done. Okay. The square calculation is already done. So the return location R2, which you have seen in the previous slide, is now not available. It is solved. So you have now top of the stack is again pointing to your return location R1. Okay. So you can see whenever you are calling a function inside another function, one new return location is added and top of the stack is pointing to that. So at any point of time, wherever the top of the stack is pointing, that calculation will be done. That is the idea of your stack, right? Now come to the global and local variable. I already mentioned about the global constant, global variable and local variable. But here I will tell you how to assess the global variable within a particular function. So it is possible to declare the local and global variables of the same name. You can declare x as a local variable, x as a global variable. But if you want to assess the global variable, you have to use scope resolution operator. And it is a unary operator to assess the global variable when a local variable is having the same name and available in the same scope. Okay. So the unary scope resolution operator cannot be used to assess a local variable of the same name in the outer block. Outer block it is not allowed, but within that you can apply. Right. Let us see an example to clear our idea. So here you can see I have declared a global variable. The name of the global variable is number. Okay. And what is the value? The value is 7. And inside the main function, what I did, I declared the same name. This is a global variable, but inside the main block, I have declared a local variable, but the name of the local variable is same as your global variable. Both are same. The type is, return type is different. The return type is here int, here the return type is double. Okay, but the name of the variable is same. Okay, and the values are also different. So if you print this number inside the main function, what you will write? Local double value of number is number. If you write like that, then 10.5. But if I tell you, you assess the value of this global variable, you can print a message like global int value of number. You have to use the scope resolution operator prior to the variable name. It is a unary operator. Operator means your -5 is a unary operator, +5 is a unary operator, plus, minus. Okay, whether it is pre. Similarly, here scope is your unary operator. So whenever you write column number, it is going to print 7. Okay. You have to use the scope resolution operator, right? Now come to function with empty parameters. You can also define the function without any return type. Non-return type is void. You know, void means nothing. So I am writing void print. The function name is print, but it is having empty parameter list. Okay, parameter list is empty. You have not specified any parameter. So this particular function specifies that function print does not take any argument. It is not taking any argument. There is no argument and does not return the value. That's why whenever you are defining a function with void is the return type, that is called as a non-return type. Okay, then you should not write return 0 at the end of the function. As you are writing int main, you are writing return 0. But many compilers not supported that. That's why we are writing int main in general, right? Okay. Now see, let us come to the second point of discussion that I mentioned you, that is called as your inline function. So C++ provide another feature that is called as your inline function in order to save the execution time. Or whenever you are calling a function, what happens? The control is moving from the main function to that function. That function is going to calculate some calculation. Again, the value will be returned to the main function. So this leads to your execution time overhead. So what is the solution? The solution is nothing but your inline function to reduce the overhead for the small functions. If there is a small function, in order to avoid the time, or in order to avoid the overhead, or in order to avoid the execution, longer execution time, what we did, we are using inline function, right? But bigger function case, inline function is not good, right? So placing the inline before a function return type. You know how to declare a function. Just prior to that, if you write a keyword inline, okay, in the function definition, okay, return type, then that is called as your inline function. That's why placing the qualifier inline before a function return type in the function definition advises the compiler to generate a copy of the function body code in place to avoid a function call. So I'll tell you an example. See here, our execution starts from the main function. We have declared a variable that is called a side value, right? Then I am asking enter the side length of your cube. Okay, so once you supply the value, okay, side length of a cube, we are going to calculate. You have to multiply it 3 times in order to calculate the cube. Okay, in order to calculate the side, what we call that, volume of the cube. Okay, you have to give input of one side, then I will multiply that value 3 times in order to calculate the volume. Okay, suppose you have written here enter the side length of the cube is nothing but 3. Okay, user has given input here and the side value now contains 3. Then I am calling the function. Okay, volume of the cube with side. Okay, the side value 3 is nothing but cube of side value. So here the side value is nothing but 3. Okay, so you can see here the function prototype is not there or function declaration is not there, because whenever you are calling the function, prior to that the function part is there, function definition is there. If function definition is there prior to the main function, function prototype is optional or function declaration is optional. So whenever you are giving this value 3, okay, so it is calling this function. But in this function, you have written a keyword inline. So what happened? Earlier what happened? Without this inline keyword, 3 is copied to the side. Then you are calculating 3 into 3 into 3. Whatever value it is coming, you are displaying here. But if you are writing inline prior to a function, like here you can say cube is the function, double is nothing but your return type, and inline is nothing but a keyword. So it is an inline function. The body of this particular function is now available here in order to save the time. Okay, that is the advantages you are going to get if you are going for inline function. Okay, so it will not go to again the function and do the calculation, but the entire body is available inside the main function, so that the calculation will be much more faster. Okay, it will be much more faster, right? That's why we are using the inline function. Right, but for the bigger program, what happens? If you replace everything into the main function, again it will generate the overhead. That's why I mentioned that inline function you will use in the case of smaller function, not for the larger function. If smaller function phase you can use, then replacement if you do, then that is okay. But for larger function, again the overhead will increase. That's why it is applicable to smaller function only. Next come to references and reference parameter. So I told you about call by value. Now we are going to see another part that is called as call by reference. We also call as pass by value, pass by reference. In the pass by value case, I told you, suppose you are not writing the class node. So in the exam, you are doing the Xerox of that particular node, right? But if anything you are modifying in the Xerox part, Xerox node, that will be not affect your main node. That is called as a call by value. But whenever you go for call by reference or pass by reference, if you modify something in the Xerox copy, let's say you are calling your friend and you are saying page number 36, you have written the value as 5, but the value is 10. So your friend is going to modify in the main copy, right? That is called as a call by reference. Means whenever you are duplicate your data, so you have to ensure that all the data should have the same value. So that is called as a call by reference. So before illustrate you that what is call by value and call by reference, let us take an example. To indicate that a function is passed by reference, simply follow the parameter type in the function prototype, that is ampersand. So earlier you are using int count, but here we are using int ampersand count. Ampersand count means we are providing the address of that particular variable. Okay, whenever you are writing count, in computer memory count is there, right? Let's say count value is 5. and count value 5 is occupied some memory location. Let's say the memory location is 1000. But when we are writing ampersand of count, we are not pointing to the value, we are pointing to the memory address. Okay, if you point out the memory address, whatever modification you do in the Xerox node, that will be affect to your maintain node, right? So let us see an example to clear your idea. So you can read this statement, that is int ampersand count, from the right to left. That is nothing but count is a reference to the integer, right? In this way you can read. Now let us see this example. I hope the idea will be more clear in this example. Now execution starts from the main function, and here you have declared two function declaration. One function name is square by value, another is square by reference. Both takes two parameter. One is taking int parameter, integer type. Another is taking parameter of integer, but there is a ampersand. Ampersand indicates you are going to provide the address of that particular variable. See here I have declared two variable. One is x, right? X value is 2. And I have declared z and assigned the value 4 to z, right? Now what I am doing, I want to show C out x is equal to x. So with the output, x is equal to, your x value is 2. So 2 before square by value. So it will print the message before square by value, right? Before square by value, right? Now value returned by the square by value. In the next line it will write value returned by the square by value, and you are calling the function square by value of x. What is the x value here? The x value is 2. So whenever you call this function, it will come to here. This 2 is now coming to this square by value. It is replaced by number. The x value is same as the number. What you are calculating? You are calculating number star is equal to number. What it indicates? Number is equal to number into number. I told you shortcut operator. If you want to write a is equal to a plus 1, you can write a plus is equal to 1. That indicates a is equal to a plus 1. Similarly, in this case, you can say number is equal to number into number. So it is nothing but 2 into 2, right? Number into number, 2 into 2, that is 4. So 4 will be returned here. Okay. So in your output, you are going. Then what you are doing, you are printing the value of x after the square by value. So to print before the square by, before calling the square by value function, the value is 2. After the square by value, also the value is 2. So you come to our example, means what happened? What made, but that is not affecting the main code. So that is called is your pass by value or call by value. To the second one. In second case, what happened? You are printing the value of z. Right? Z value is 4, so it is pointing 4. Now you are calling the function reference z. So what is the z value? The z value you are supplying 4. Z will come to here. But what you are doing, you are not giving the value. You are giving the address of that value. That's why I have written ampersand. Ampersand indicates address of that variable. Okay. So what happened? What happened? In that particular function, you are calculating number reference is equal to number reference into number reference. So you have supplied the value of 4. So here it is nothing but 4 into 4. So what is the value we are going to get? 4 into 4? That is 16. Okay. We get 16. The original value is now changed to 16 because you have given the address. When you are printing the value of z, that is nothing but after the square by reference, you are going to get 16. Right? But previous case, what happened? Earlier the value is 2. After that the value is 2. Only whenever you are returning this value, the value is coming as 4. But in this case, what happened? The value is 4 prior to the square of by reference, but after the square by reference, the value is printed to 16. And if you print the value of z, that is you are going to get 16, not 4. So that is the concept of call by reference, or you can say your pass by reference, right? Now come to another concept that is called as default argument. So to invoke a function repeatedly with the same argument. Okay, if you want to invoke a particular function with the same argument, suppose I will tell you, you supply 3 values. So you will say, no sir, I will supply only 1 value. So rest 2 value will be taken from the default value. Okay. So in such cases, what happens? You can specify that such a parameter as a default argument. I have asked 3 input, but user is giving only 1 input. User is not interested to take another 2 and next 2 input. So we are going to take the default argument. But whenever you want to specify such argument, you must be define such argument in the rightmost argument in a function parameter list, not in the leftmost, rightmost part. Okay. So when calling a function with 2 or more default argument, it may happen that one function can contain more than one argument, default argument. So if you have omitted such argument, is not the rightmost argument in the argument list, then all arguments to the right of that argument also must be omitted. So we'll see one example to clear this idea. See this. You have declared a particular box volume, which takes 3 parameters, and the default value I have already mentioned. The default value of width is 1, the default value of width is 1, the default value of height is 1. Inside the function, what I am doing, I am printing a message that default box volume is function. As I am calling the function without any argument, it is going to take the default value. Default value means the length is 1, width is 1, and height is 1, and it is going to calculate 1 into 1 into 1 and return 1 here. Now in the second case, what I am doing, I am calling box volume of 10. I am supplying one value. Means I am supplying the value of length, that is 10. But I am not supplying the value of width and value of height. So value of width and height will be taken as the default value, and it will calculate 10 into 1 into 1, and it will display 10. That's why I mentioned whatever the default value is there, that should be present right side of the list. Okay, like here you can say width and height is the default argument. They are taking default argument, so they should be present in the right part. Similarly, box volume of 10 and 50. So here the length value is 10, width value is 5, and height is not there. So height it will take default argument. So that is 1. 10 into 5 into 1, it is going to print 50. In the last case, I am supplying 3 parameters, 10 and 5 and 2. So it is going to calculate 10 into 5 into 2. That is nothing but your 100. So what we have seen here, you can supply a subset of the arguments in a particular function. So in such cases, you must ensure that you have defined the default values. Otherwise, you will get an error, uninitialized error. Okay, so you can specify the default argument, like here I have mentioned the default argument, right? Now come to the same function overloading. I'll tell you because we are going to see in a different angle. So C++ enables several functions of the same name to be defined as long as they have different signature. Different signature means different arguments. Okay, that we call as a function overloading. C++ compiler select the proper function to call by examining the number, types, and order of the arguments in the call. Okay, and function overloading is used to create several functions of the same name that perform the similar task, but on the different data. One may be int, another may be int double, another may be double int, another may be double double. Right? So that is possible. So this is the example what we have discussed. I'll tell you again. So what we did here, in the main function, I am writing square of 7. So 7 is an integer type. You can see here there is 2 functions. One is square, another is also square, but their argument is different. Here the argument is integer type, here the argument is double type. So whenever you are giving integer, it is calling the function 1, and it is returning the value 7 into 7, that is 49 it will come. Right? But whenever you are giving the value 7.5, it is not calling the first function. It is calling the second function, and it will return 7.5 into 7.5 as the output, right? So this is with the int argument, integer argument, and this is with double argument, right? That is the concept of our function overloading. Next part of discussion is called as recursion, right? So a recursive function is a function that calls itself either directly or indirectly. So if you go for the concept of recursion, you will call the same function with different value repeatedly unless a particular condition is satisfied. Okay? It's called to solve a particular problem. The function knows how to solve only the simplest case, that is called as a base case. For other cases, you don't. So when you apply the process of recursion, you are going to get the values. Okay. So if the function is called with a base case, the function simply returns a result. But apart from the base case, whatever case you are calling, you have to go in the process of recursion. But base case value is already given, right? So in order for the recursion to eventually terminate, you have to specify the base condition. Each time the function calls itself with a slightly simpler version of the original problem. First problem may be complex one, but the second problem is a little bit simpler one. Next problem is like that you have to read base case. Okay? And this sequence of smaller and smaller problem must eventually converge on the base case. So at that point, the function recognizes the base case and returns a result to the previous copy of the function. So if what is the value of x, you are going to tell me the value of x minus 1. If the value is x minus 1, then you will ask x minus 2, x minus 3, x minus 4. So whenever you reach to the base 1, again you have to go in the process of backtracking. Okay, you have to solve all the problems. Finally, you are going to get the result. Like one of the example, very famous example for the recursion, that is nothing but factorial of a number. So whenever you go for a factorial of a non-negative number n, written as n factorial, so how you are calculating? If somebody will ask n factorial, you will say you calculate the value for n minus 1 factorial. If somebody will ask you n minus 1 factorial, then you will say n minus 2 factorial. Until unless you reach to 1 factorial or 0 factorial, you are go on asking. You tell me n minus 1, n minus 2, n minus 3, n minus 4 factorial. Right? So in this case, you can apply the process of recursion. Right? So with 1 factorial, you know the value is 1. With 0 factorial also, you know the value is 1. But whenever somebody is asking 5 factorial, you are asking, give me 4 factorial. 4 factorial, then you are asking 3 factorial. 3 factorial, you are asking 2 factorial. 2 factorial, you are asking 1 factorial. Your base condition is 1 factorial, that you know that value is 1. Or 0 factorial, you know the condition value is 1. There you can go in the reverse process, right? So in this way, if you calculate, you are going to get the value is 120, right? So the factorial of an integer number, okay, greater than or equal to 0. So it can be calculated iteratively or it can be calculated non-recursively. That is the same thing, iteratively or non-recursively by using a statement. Like I have declared a for loop, I have defined a for loop. The counter is nothing but number. Counter is greater than equal to 1 minus counter. I am going to calculate factorial is equal to factorial into counter. Okay. So in this process, what we are doing? You are doing iteration. First case, the factorial, the number. Okay. Let's say the number is 5. Okay. So for 5, you are iterating once. Next, the value will be declared decreased to 4. So you iterate 1. 3, you are iterating 1. 2, you are writing 1. 1 case, you are iterating 1. 0 case, this condition is not satisfied. So up to that, you have to execute factorial is equal to factorial into counter, so that in the 5 case, you are going to get 120. But recursion case, we are not doing that. Recursion case, what we are doing? If somebody is asking 5 factorial, we are telling, yes, 5 factorial is nothing but 5 into 4 factorial. So you are going to solve now 4 factorial. 4 factorial into 3 factorial. So you solve 3 factorial. So a recursive definition of a factorial that is nothing but n factorial is equal to n into n minus 1 factorial. Like 5 factorial is 5 into 4 factorial. Similarly, you are going on calculating 3 factorial, 2 factorial, 1 factorial. So once you reach to 1 factorial, you know the value is 0, or when you reach to 0 factorial, you know the value is 1. Sorry, 1 factorial it is 1, or 0 factorial you are getting 1. Until you reach to the base condition. So that is called the process of recursion. So iteration is not recursion. Both are different. Recursion is different. Recursion you are solving, iteration you are solving the same in each and every case. So they are different to